Welcome to the Femap version 11.3 What's New video series.
SolverSupport. For Abacus, we've done a lot of work over the last couple of years with attaching high-speed attachment to results from Nastran OP2s, XDBs, comma separated in our own binary results file. But now we also do the Abacus ODB file. And we're using the toolkit provided by Abacus, which is actually pretty nice. First of all, it worked. It was easy to incorporate, but it also does kind of automatic versioning. If you've got an old Abacus ODB file, their tool, when you go to attach and use their libraries to access it, automatically knows what version it is. It gives you back the right results. So just like using OP2s, XDBs, and attaching, you now just pick an Abacus ODB file and we attach to it, pull everything out of there, when it's needed, and then if you want to internalize it, same tool. You can say bring it in the Femap database permanently if you want to. Nastran, obviously, with Siemens and NX Nastran and all that, and even a lot of our customers still run an MSC Nastran. People's processes are kind of built around Nastran and how they do it. So a customer came to us, and we have these studies now. If you read in your modal run or a transient run, everything goes inside of one study. That study used to get kind of just a title, or just say modal or static study, or transient. It now can optionally get the file name that you read the results from. So if you're naming your file something that means something, you're going to see it as your study title, which is nice. We also had a customer that their subcase IDs in Nastran obviously meant something to them. Like case 301 was a 4G pull-up, and they want to know that it's 301. So Femap will now bring in that subcase ID and put it in as part of the title. So now you'll see case 301. You know where it came from. You know what it was. And there's also versioning, so if you read it in a second time, we will show you an R1 and R2 and R3 as you read them in, so you kind of know what's going on. Another thing here, for Nastran enhancements, we now handle pretty much, I think it is all the quality checks that Nastran can do. So we got the source code from the NX Nastran team, and we do the exact same quality checks. So if you want to match what gets spit out of Nastran, you can do that in Femap where you visualize it by like a contour or criteria, or in our listings and all that stuff and data checking. You can use all the exact same Nastran element quality checks that Nastran uses. Another small enhancement for our Dynamics folks using Nastran, we now support all the freak cards. So freak nothing, freak 1, freak 2, freak 3, 4, and 5. And the real nice thing you can do is they're actually across your model. So if you set up these frequency specifications and you create an analysis set, they all have checkboxes, so you can use, and you create another one, you can use the same ones in another analysis. And you can copy in between models if you set up a bunch of important frequencies to you. So if you're a frequency response guy or a dynamics guy in Nastran, you should really appreciate using these. Just to give an example, and if you pick certain ones in the analysis setup, those are the ones that go out. And we read these just as well as write these, so it'll bring in all the different freak cards from your Nastran bulk data files. For years, we kind of followed the Nastran convention. If you want to do enforced displacements, you created it as a load, and then you had to go in the constraint set and actually constrain the same degree of freedom, because that's just the way Nastran worked. But we also now support, you can create non-zero constraints as SPCs. So just as, now you just need a constraint set, you can put the numbers on, and you can have enforced displacements on your model without having a load set. And again, read-write, if someone sends you an existing model that already had this in it, we read it in and support it now. Another small thing in Nastran, if a C-bush or a CLAS, if node 2 is blank, that's a spring to ground. We now support that. So it's actually a new element type. You actually go create a spring to ground element, and there's only one node you put in, but it'll automatically create that. So you don't have to go create a node, constrain it, and do all that stuff. You can just do it automatically. Read-write, all that works. So it should be useful to anyone that just wants to put some stiffness into their model in certain places. And it works with the C-bush and the CLAS. Again, a lot of our customers are running Nastran and as well as other codes. Femap can launch and run. If you have the solver available on your machine, we can actually launch and run it automatically. We took care of all that with environment variables in the past. It's getting harder and harder to even explain to people what environment variables are or where to find them in Windows to set them. So now we do it right in the GUI in Femap. You can now tell it where your ANSYS solver is. You can tell it where your Autodesk Nastran or Dyna. You tell it where it is, and you have additional command line arguments if you need to feed something in from memory or whatever you do. So then when you hit Analyze with Femap, it'll go out, find that solver, launch that, run your job. Some other small Nastran things. Within each job you set up or analysis set you set up in Femap, we actually added another command line here. We have people that want to run a different command line for every job they run, depending on how big the model is and how much memory it might need or other options. So you can now do that by job in Femap. It'll get sent over to Nastran when it runs. And we added some more options on the GPU computing. We found that the GPU computing, it accelerates certain parts of the solution sequence in Nastran, and I think it actually decelerates other parts. So with this thing, you control which parts you want the GPU to work on. We've added some Dyna stuff. Again, this is actually kind of launch control and setting up the jobs and getting them running, and then we continue to add material property support. We've also added a user-defined material for Dyna where you can set up any Dyna material. You just tell it what the keywords are, what values you want. So now you can actually handle any Dyna material. You can kind of code it up yourself. We hired a gentleman who's an ANSYS developer for a long time, and the first thing we did was we let him loose on our ANSYS interface, which kind of made sense. And he went through and found, his mind's a little more ANSYS-centric, we're a little more Nastran-centric, so he went and cleaned up a lot of stuff in the interface. Same thing, took care of the job control stuff to make it more modern and do all the right ANSYS things. And the other thing we had him do, if you're running your ANSYS job on your own local machine while it's running the ANSYS solver, you get the same feedback. It monitors the job, and you see it processed just like we do for Nastran. And he also was looking at element support. And he said, hey, a lot of these, we do have a lot of, the C-bush element's real important to a lot of our customers for modeling fasteners and all types of things. ANSYS doesn't have one, but he looked at it and realized, hey, I can write out, looked at the formulation for the C-bush, writes it out as a matrix 27 to ANSYS. So now you can take your Nastran model and run it in ANSYS and get the exact same answers if it's got C-bushes in it. And he did that by grabbing the stiffness data, the damping data, and filling in all the details here in the stiffness matrix. And you don't have to worry about it. It does it all for you automatically. You can now take your Nastran models and make exact ANSYS models with C-bushes in them. And while he was in there messing with the stiffness matrices and such, we had a stiffness matrix element in Femap for like a general element. He went and updated that to match all the stuff so you could put in the big full matrix 27s into Femap and maintain them and keep them if you want to do it that way. Same thing that we did the non-zero constraints in Nastran with the SPC. He did that also for ANSYS and Abacus. So if those exist in your model, they'll get written out correctly so that they'll run the same in ANSYS or Abacus. And he also did the CLAS. I already told you the CLAS and the C-bush to ground. All those are taken care of.